Okay, question number 11, maximum marked 17 points. Find the first four term in the binomial expansion of square root of 1 plus 5x in the ascending power of x. It says first four terms. Okay, question number 8. First four terms of square root of 1 plus 5x. This can be expressed 1 plus 5x to the 1 over 2 power equals, I can directly expand it, 1 plus 1 over 2 combination 1, 5x, second term, plus 1 over 2 combination 2, 5x squared, third term. Last term will be 1 over 2 combination 3, 5x cubed. Okay, equal 1 plus, that one is 5 over 2x plus, that's the 1 over 2 combination 2 is 1 over 2 minus 1 is negative 1 over 2, 2 factorial is 2, 5x squared is 25x squared. Okay, plus 1 over 2 combination 3 is 1 over 2 minus 1 over 2 minus 3 over 2 over 3 factorial is 6. 5x cubed is 5 cubed is 125 x cubed. Okay, simplifying this, we got 1 plus 5 over 2x. See, 2 goes, check for the sign first. This is only one negative, so it's gonna be negative. And then 2 is, denominator is 8. And then numerator is 25 x squared. Plus, next one, check for the sign, minus is gonna be totally plus. And then we have 6. So this one goes 2, so we have 1 2 3 4 2's is going to be 16 on the bottom and 125 on top, x to the third power. So this is going to be the answer. Okay, next question. Consider the expression like this, where PQ is a rational number. Find the expression of this one, ascending power of x, up to including to x squared. So this expression is already simple, and then we have to make this expression by binomial expansion. So, so this expression equals 1 plus px, and then 1 plus qx to the negative 1 power is 1 plus negative 1 combination 1 q of x plus negative 1 combination 2 q of x squared. So it's going to be q squared x squared because only x squared we need. So this one we have 1 times 1 is 1 times 1 is 1 plus minus, yeah, let's simplify one more time. So it's going to be 1 plus px, 1, this is minus q of x, this one over here, minus 1 combination 2 is minus 1 minus 2 over 2 factorial is 1. minus 1 minus 2 over 2 factorial cancels out, it becomes just 1. So plus q squared x squared, okay, equals, first term will be 1 minus q of x plus q squared x squared. Next term will be plus px minus pq of x squared. Next term will be x to q. We don't need it actually. So this expression over here is not actually equal, is approximation like this. So we can say 1 minus 1 plus p minus q of x plus q squared minus pq of x squared. So this is the answer. Okay, expand found in the part A and B are identical up to the first three terms. First three terms is 1, 2, 3 terms. 1, 2, 3 terms. For the value P and Q, sure that Q is 5 over 4. So this and that one is same, so which means that 1 is same. So P minus Q equal 5 over 2, and Q squared minus PQ is minus 25 over 8. So what that means is P minus Q should be equal to 5 over 2, and then Q squared minus PQ must be equal to minus 25 over 8. We have to solve this system equation to get the Q value of this. So we all have to do to get rid of P, right? So from this equation we can say Q so don't make it complicated. So from this equation we can differentiate. We can not differentiate, factorize. Q in front is going to be Q minus P equals minus 25 over 8. Here is Q minus P. So from this expression we can say Q minus P is the other way around. So minus 5 over 2. Plug in this value into that value. So that means Q times minus 5 over 2 equals minus 25 over 8. And cancel out the sign, and this one becomes 1 and 5. So Q equals, multiply 2 on both sides, becomes 5 over 4. Yeah, then we got Q 5 over 4. Q 5 over 4, got it. The expression this with P is 15 over 4 and Q is 5 over 4 can be used as approximation of this expression. So in the question it says that this is exactly same when P is this value and Q is this value. So what it says is this expression is exactly 1 plus px is 15 over 4. There's no space here, so let's see, just delete up this one, and then say 1 plus 5x squared inside of square is 1 plus 15 over 4p, no p, this is x, right? X over 1 plus 5 over 4x. So this is not equal as approximation. So this expression is approximated like this. Using this, and x absolute value of x must be less than 1 over 5 to have a convergence. Hence, the finding a suitable value of x, find the approximation of square root of 1.2. So square root of 1.2, okay, what should we put on 5x? So see, so 1.2, so this one inside should be equal to 1.2. So 1 plus 5x should be 1.2, which means that 5x should be 0.2. So x is 0.04, right? X must be 0.04, plug in. So, okay, this expression, when x equals 0.04, this expression becomes square root of 1 plus 1.2. 1 plus 5 times 0.04 is 0.2, which is exactly square root of 1.2 equal, right hand side becomes 1 plus 15 over 4. X is 0.04, which is 4 over 100 over 1 plus 5 over 4. X is times 4 over 100. Final value of this one. We multiply 400 on top and 400 on the bottom, and we got this cancels out, this cancels out, and we got 15 times 4, 60 plus 1, 61. Over, oh, not 61, okay. So 400 on the top means we got the 400 plus 60 divided by 400 plus 5 times 4 is 20. So 460 over 420 equals, let's divide by, it's going to be 46 over 42 equal, divided by 2 is 23 over 21. So this is the answer. So this is equal to 23 over 21. Okay. Now consider the approximation of square root of 5 over 2. Explain why approximation for this expression is not as accurate as approximation of this. This one, okay. Square root of 5 over 2 can be expressed as the square root of 5 over 4, everything inside. So square root of 1.25. So square root of 1.25 is when x equal, so let's see. So 1.25 is 1.5x equal 1.25, means 5x means 0.25, x is 0.05. So first trial was when x, this one here, when x equal 0.04, we get the approximation for square root of 1.2. So when x equals 0.05, we have less accurate approximation because x 0.05 is closer to this value. X absolute x is less than 1 over 5, which means absolute x is less than 0.2. X is between 0.2 and 0.2 negative. So whenever this value is inside here, even though 0.05 is inside this range, if this value is closer to the limit, closer to the right limit, which is 0.02, it is less accurate. It is less accurate. This is why. So whenever we put some x value closer to on the middle, it will be more accurate. Whenever x value is approaching 0.2, it is less accurate. That is the reason.